Well, welcome back to further examples. We're going to start here with ammonium. It is the one polyatomic ion that has a positive charge. We've already counted up the electrons. There are 8. Nitrogen goes in the middle. Hydrogen never goes in the middle. So we're going to put our nitrogen in the middle here. We're going to make our single bonds to all the hydrogens. I have good news. We've used up all of our electrons, so our Lewis dot structure is finished. All right. But now we have to figure out which atom is going to have a formal charge of +1 because we want all the formal charges to add up to the charge of the compound. The 4 hydrogens here bring one, they're supposed to have 1 valence electron, and each of them puts 1 electron into the single bond. So the formal charge for each hydrogen is 0. Let's look at nitrogen. Nitrogen is supposed to have 5 electrons, but it puts 1 electron in each of these single bonds. So it appears to only have 4. It's supposed to have 5, only has 4, which gives us a formal charge of +1. And I have more bonus news. No resonance structures. There are no double bonds for us to move around in this case. Let's move on to the azide ion. This is in, as I said before, it's what's in airbags. All right, there's 16 valence electrons. The nice part here is we know that nitrogen goes in the middle. It's N3 minus 1. So we're going to get a nitrogen in the middle, N and N. So we used up 4 electrons. We have 12 electrons left. Hooray. All right, so let's fulfill the octet for the nitrogen on the left. I've used 6, and I'm going to fulfill the octet here. I've used 6. I have no more valence electrons. So now what we have to do is figure out how we're going to fulfill the octet rule for that nitrogen in the middle. There's a lot of ways we could do this. I'm going to start with a symmetric way because I like symmetry. All right? I'm going to remove that lone pair of electrons, and I'm going to put it in here to form a double bond. I'm going to remove that lone pair of electrons, put it in here to form a double bond. All right? So now the octet rule is fulfilled for everything, but we have to do formal charge. We always have to do formal charge. It's very important. Let's start with this nitrogen on the left. Nitrogen is supposed to have 5 electrons. Well, 1, 2, 3, 4, 5, 6. It appears to have 6 electrons. It's putting 2 electrons into the double bond, so that's 2, 4, 6. All right? If it's supposed to have 5, but it looks like it has 6, that means it's got a formal charge of -1. As you can see, the nitrogen on the right looks exactly the same, so that has a formal charge of -1. Now let's look at the middle. This nitrogen in the middle is putting 2 electrons into this double bond and 2 electrons into that double bond. That's a grand total of 4. Nitrogen is supposed to have 5 electrons, but it looks like it has 4. It has a formal charge of +1. And if we add up these 3 formal charges, we get -1. On to our fun time of resonance. We can look at this and actually can move some of these double bonds around. All right? So I'm going to take this double bond, or excuse me, this lone pair, and add it to this double bond to make a triple bond, which means this double bond has to kick out 2 electrons to make a single bond. And we end up with something that looks like this. All right? And if we go through and do our formal charges here, we get nitrogen supposed to have 5 electrons, 1, 2, 3, 4, 5. It's got a formal charge of 0. This nitrogen is still making 4 bonds. 3 electrons are in the triple bond, 1 is in the single bond. So it only has 4 valence electrons, supposed to have 5. Formal charge of +1. Out here, 1, 2, 3, 4, 5, 6, plus the 1 in the single bond gives us 7 valence electrons. Nitrogen is supposed to have 5, in this case it has 7. That gives us a formal charge of -2. Then we could also go down and write this a different way. And as you can see, this is just the triple bond is flipped to the other side. And so we get a formal charge of -2 here and +1 here. So I didn't mean to write that 1. You add all these up, they still equal -1. So here we have 3 different resonance structures for the azide ion. No problems. Finally, let's talk about acetate. All right? We have 24 electrons. Hopefully we've drawn enough so that you can see that CH3 group looks something like this. Okay, so we have our CH3 group up, this last bond is to this carbon, and now we have this carbon double bonded to one oxygen and single bonded to the other. Let's do our formal charge. The formal charge for the 3 hydrogen is 0. The formal charge for this carbon is 0. For this particular carbon, it's also 0. Carbon should have 4 valence electrons. 1 plus 1 plus the 2 it puts in the double bond give us 4. So formal charge of 0. Oxygen, 1, 2, 3, 4, 5, 6. Formal charge of 0. This particular oxygen. If you look back, whenever oxygen forms as just one single bond, its formal charge is usually -1, usually. So we have this. Great. But there is one resonance structure. And if we redraw this, that double bond can change spots, and we get a formal charge of -1 on that oxygen. So these are, if you watch the previous video, there are 5 examples of how to draw ions and utilize formal charge as well as resonance structure. These are important concepts because they help stabilize compounds. Resonance is one of the reasons why beta-carotene is so good for your eyes and how your eyes work. It allows your eyes to absorb a lot of different wavelengths of light.